We're on to question 8. It's a trigonometry question. And you can see here we have a conversion of 7.5 kilometers to meters. So remember, there are 1,000 meters in each kilometer. So we're going to have 7,500 meters. That's part A. Now let's look at this diagram down here with this flight of the plane. So we need to find this angle in here, the angle of inclination. But we have a meters value and a kilometers value. So we have converted this to meters. So we're going to stay with that scale. Now let's focus on the diagram. So we have the opposite side and we have the hypotenuse values available. So therefore we're going to use the sine. So we have the sine of the angle E is equal to the opposite over the hypotenuse, which is equal to 200 meters over 7,500 meters. Now we're going to use the sine inverse function for angles. So get the sine inverse of each side and we'll get the angle E on the left hand side and the sine inverse. Use your calculator with the fraction. We have 200 over 7,500 and this will give us a value of 1.528 degrees. We're going to round that up to 1.5 degrees to 1 decimal place. Now we're going to convert 20 minutes into an hourly scale. So we're going to put 20 over 60 minutes in 1 hour. Put into your calculator, use the change button or press equals, and we can see that that will give us 1 over 3 in fraction form. Now let's go on to the part 2. We have a speed, distance and time question. So the plane traveled 598 kilometers in 2 hours and 20 minutes. So we have a distance and a time. So let's use the speed, distance, time triangle. You can see here speed is equal to distance over time. Now we're going to use the 1/3 as well for the 20 minutes here. So the speed is equal to distance over time, which is equal to 598 over 2 and 1/3. Okay, so 20 minutes is 1/3 of an hour. Put it into your calculator like that, and we'll get a value of 256.28, and that will be 256.3 kilometers per hour. So always look back at the question just to check the units. Now finally we're going to work on a composite. We have a triangle here and here. So we need to find this total value, this horizontal distance A to C. So let's focus on the left hand side. So we will have a triangle with, if we redraw it upright, we can put 280 here as the opposite and 598 then as the hypotenuse. So we have 598 and we're going to just write out Pythagoras theorem. We have a squared, hypotenuse squared is the sum of the opposite two sides squared. So let's input all our values. We have 598 on the left hand side. We have B as the length AD and we have 280. So we're going to square them out and get the difference. Okay, so b squared is equal to 598 squared minus 280 squared. So be careful to put a negative here, as when we bring this across, we'll subtract it rather than add it. So when we work that out, we will get b is equal to the square root of 279204, and b is equal to 528.39. So we'll just round it to 4, and that's kilometers. So now let's go on to the other triangle here, and we're going to use trigonometry ratios again. So if we redraw it, we can see that this value here, DC, will be the adjacent, and this value here will be the opposite. So therefore we're going to use 10. So 10 of 35 degrees is equal to the opposite, which is 280, over the adjacent DC. So what we need to do here is a swap. Okay, if this is below, we can multiply up and then we can divide down by the 10. So a very useful step there, just swap them. So we're gonna get the length DC is equal to 280 divided by the 10 of 35 degrees, and we get a value of 399.8. So we have 399.8 over here, and then we have 528.4. So when we plus both of those together, we're going to get the total length. So we're going to get 928 kilometers.